Good evening, everybody, and welcome to our Distinguished Speakers series. You know, we academics, we get so enthusiastic that we often use terms like influential and distinguished very easily to describe, people who are doing research that we believe in. But sometimes we use those terms because they're the correct terms, or the right terms. And tonight, they are the right terms for our guest speaker. And it's a real pleasure to be able to introduce the influential and distinguished Dr. Jay Famiglietti. And let me tell you a little bit about him. He has degrees from Tufts University, and his PhD is from Princeton University. He went also to the University of Arizona for a master's degree in hydrology. His career has been remarkable. He taught at the University of Texas at Austin for a few years and then moved to UCI, where he founded the Center for Hydrologic Modeling. And the work that he has done there using remote sensing data to help us track and understand the performance of groundwater, an area that was largely sort of like, what he's done for groundwater is sort of like what the Cousteau family did for the oceans. He's brought it to life, he's made it real for us. He's given us an insight that 15 or 20 years ago we did not have. We had a huge amount of information about surface water, but we knew very little about groundwater. And this work has been widely recognized. He was the recipient in 2012 of the Birdsall Trice Distinguished Lecturer Award. His work was showcased along with his character in the very widely acclaimed documentary film, Let's Call It the Oasis. I imagine some of you have seen that film. It was premiered here at UCI among other venues. A wonderful film. If you haven't seen it, get on Netflix or whatever and take a look at it, because it makes Jay look good, it makes UCI look good, but it also helps us orient ourselves on this very controversial and important question. He's also a regular blogger for National Geographic's Water Currents, a distinguished author of numerous publications. He and I worked together on the Flood Rise project, which I don't know if I mentioned before, but was showcased in the UCI magazine a couple of weeks ago. I encourage you to take a look at that as well. He's currently a professor in civil engineering and also in earth system sciences here at UCI, but he is on loan right now to NASA's Jet Propulsion Laboratory in Pasadena, where he serves as senior water scientist. He's received a great deal of attention throughout his career, but especially in the past few weeks because of his views on what remote sensing is telling us about this 4-year drought that we are experiencing here in California. And if you've been following the news lately, you are well aware that there's a wide sentiment that Californians have not yet taken this drought seriously enough and have not yet thought through some of its economic and social and ecological implications. So we're really, really fortunate that Dr. Famiglietti has taken time out of his schedule to come down from Pasadena to talk to this class about what remote sensing tells us about water generally, but specifically about the challenges that we're facing here in California today. So please join me. Welcome, Dr. James Famiglietti.
And so it's always a pleasure to come. I think I've given a lecture or participated in the judging of the videos for several years, and it's always great to come to this class. It's a huge class. There's a great vibe. I love that it's in the evening and that everyone comes out for it. I actually tried to do a class like this. Tried to do an evening class based on my experiences with coming to your class, and my department chair said, "No, we don't do that. We don't do that. We're not going to do that." So anyway, who has been following the drought? I'm curious to know. I don't really see enough hands. So what is your general sentiment? A problem? I think it's like we have 3 levels: a huge problem, a sort of a problem, I don't really care. So who thinks it's a huge problem? Good. That's good. Well, you have to answer that way. Who thinks it's a sort of a problem? Not many people. And who doesn't really care? Who thinks they're unaffected, right? Yeah, well, you're in a sustainability class, so that's good. Yeah, so it turns out that it's a huge problem, and actually, my opinion is that it's much worse than people really realize, and I'll show you why. And part of that perspective comes from the research that we do. We started here, published a bunch of papers on this topic. And part of the reason for moving to JPL on leave of absence from UCI, part of it was to get closer to the satellites and be able to get quicker access to the data, work more directly with some of the satellite engineers and think about new missions. So this is a figure that shows, it's sort of like a green, yellow, red thing. It's really resonated with the general public. It's taken from, I'll show you one of these animations a little bit later on. It's taken from an animation that's actually in Last Call at the Oasis. That's when we originally did it. But I think, the green, yellow, red colors is kind of showing cumulative water losses in California. And it's really resonated with people. I don't have many jokes, but here's one that I tell regularly. So I was made this sitting at my kitchen table up in, it's not Pasadena, we live in Sierra Madre, which is a little town which basically has no water. We have 4 wells, and so people in that town, and that's all the water we have. So people there are taking it quite seriously. So sitting there and put this together and sent it over to JPL. JPL posted it online, so this was like a Monday morning, and on Monday night, it was on NBC Nightly News. Which is very cool, right? That's a big deal for us to get something out there like that. And I thought it was so awesome, but it was Brian Williams. And so now, it's unclear whether or not we really are having a drought or not. Okay, so I put together a little timeline. We have our big society meeting, American Geophysical Union meeting in December. And so I put this together for that meeting and then updated it. And it's kind of scary, all the different events that have been happening. So we're going back to January 2014, right? So this was when the governor first declared a drought emergency. Was anyone here? Did anyone happen to be in my ESS 60B class? Yeah. Awesome. So we focused on the drought, and I should have had my dog picture. I forgot that you guys might be here. I'll talk about that later. So we focused on the drought in this class, and this was happening sort of in real time last year. So governor declares a drought emergency. The state water project cuts the surface allocations, meaning the deliveries of water from the north to the south were cut to 0. And I'll show you some of the pictures of the canals, the aqueducts. The California aqueduct that you see along the 5 is one of the main conduits. The president was out here on Valentine's Day last year, 2014. And then the other big project, the 2 big aqueducts, one is called the State Water Project, the other one's called the Central Valley Project. Central Valley Project cut their allocations to 0, meaning farmers are not getting any river water, they're not getting any surface water. And so that means they're going to have to rely almost 100% on groundwater. And I'll explain why that's a big deal. Mainly because the groundwater is non-renewable, and the surface water is, right? It rains. It hasn't rained much this year, but if we can get by on the rain and snow, everything's great. But we really can't in California, and so we supplement and make up the difference by using groundwater, the water that's stored under the ground, and that's fairly rapidly disappearing. And I'll show you some of those charts. Well, you may have missed this, but in the middle of July, Lake Mead dropped to a record low, and that's scary because it's our biggest reservoir in the United States. Supplies a ton of hydropower to Southern California. And UC Davis did a report that came out in July. And just for 2014, their estimate was $2.2 billion for 2014 of economic losses, and also a loss of 17,000 jobs. So then, in mid-July, the State Water Resources Control Board, that's a board of about 5 people that basically the governor authorizes to do things like impose these mandatory water restrictions, impose fines. And so back in July, they approved fines for up to $500 per day for wasting water. And actually, I watched a guy across the street. This could have been the guy across the street from me for all I know. I'm not the kind of person that when I see someone wasting water, I don't go up to them and say, hey, you shouldn't do that. I'm kind of wimpy in that regard. But it did, seeing a gentleman who looked much like this person, did inspire me to write some stuff about the drought that I think ended up being kind of important. So then the governor started spending money. Last August, $7.5 billion drought relief package, and he just signed another $1 billion drought relief package just a couple of weeks ago. Okay, then the biggest thing that the governor has done is sign this is in September, sign this landmark groundwater legislation that finally manages our groundwater. So it is amazing, but it will take 25 to 30 years to kick in. So it is not going to help us in the short term. And this is an issue that we'll talk about. Another $7.5 billion. We voted for that for the water bond, and it was good. I think that it was a worthy and will be a worthy investment. In fact, this recent $1 billion expenditure actually came from these funds that were previously approved. Okay, now we're starting to look at 2015, and now the big aqueduct projects, the State Water Resources Control Board said that the allocation for the state water project was 10% compared to 0% the year before. So a little bit better, but not great. Okay, so now we're in 2015. We're getting closer to the present. The driest January on record. Right? It's absolutely abysmal. And I don't know if you followed any of these snowpack numbers, but we're at about 4%, 5% of normal. I have a colleague who does more detailed work and thinks we're actually more like 3%. So we're 97% below the normal amount of snow that we would have in the mountains. And the snow and the snow melt is what fuels our streams and fills up our reservoirs. So it's an issue. This mega drought study that came out in February is really, really important, and it was really an eye-opener for me. So this is a study that was done by NASA, some guys at NASA, I think people at Columbia, and an assistant professor at Cornell. And what they found in this study was that the likelihood of having a mega drought is a drought that lasts 2 decades or more. The likelihood of having one that is unprecedented in its severity. We haven't experienced anything like it yet. The likelihood of having something like that in the second half of the 21st century, after 2050, is 80%. Okay? And when you look at some of the charts in that paper, they show water levels just going dropping off the page. That's what got me thinking about the need for long-term planning in the state, and that we really don't. We're not doing it, and we need to. Okay, so the other big project, so now 2015, the water coming down the aqueducts, 0% allocation in the Central Valley project aquifer, and I think the state water project might get to about 20%. They raised it to 20%. It was right about this time that I wrote an op-ed in the LA Times that literally went viral. I mean, people talk about stuff going viral, and I never knew what that meant before until it happened to me, and the way I knew it, that it was happening, was by the number of emails in my inbox, both crazy and mostly crazy, but lots and lots of press. But it's really the press people that said, hey, this did, our web crawler stuff has shown that this thing is viral. And so I don't know if there's a number associated with it, but a lot of people read the op-ed. I'll show you the title in just a second. It actually had 2 titles, one of which was problematic and one of which was the one that I wrote. Not that this was a response to the op-ed, but the State Water Resources Control Board, almost like the next day, in a widely sort of criticized restriction, said, okay, here's what we're going to do, big drought. Here's what you have to do. You have to ask for water when you're at a restaurant. You have to ask for it. This is like the big solution to drought. And if you go to a hotel, you should not have the towels washed. That was the big response. And so there were a lot of late night comedians joking around about that stuff. Then the governor announced this $1.1 billion drought relief package. But the biggest thing that happened was just a few days ago, on the same day, that the snowpack was announced to be at a sort of all-time low for this point in the year, 6% of, I think it must be about 5% now, but 6% of normal, so 95-ish% below normal. That's the day that the governor announced mandatory water, basically rationing. And so here we are. Now we're sort of struggling. Now people are thinking about what that means. And people, it took a few days, like for myself too, to really realize that the lion's share of the water, which we use for agriculture, was not touched. So people, especially people in the cities, are not so thrilled about that. So we can talk about that. So here's the op-ed. And so there's a little history here. So the theme of this, so you should read it. And it's only, I don't know, 800 words or something. So it's easy reading. And the theme of it really was sort of like, well, we're kind of up the creek without a paddle. I mean, the paddle meaning a plan, right? And so I was having an email exchange with a colleague, and then we were going back and forth, and I said, yeah, but we don't have a paddle, and wait, we don't even have a creek. And so that was the sort of the title. Actually, my original title was "Dude, Where's My Paddle?" And the title that appeared in print was "Up a Dry Creek," right? And so that was close, very close to what I submitted. But the title that appeared online, which is the thing and probably the reason why it went viral, was not this title. This is the improved title. The first one was "California has 1 year of water left." That was it. And then that went around the world and created a little bit of a problem for me because the press doesn't differentiate between an op-ed and a research paper that that a professor or graduate students might write. And so this was my opinion, right? It's an opinion piece, but the press picked up and it went all over the place. NASA says California has 1 year of water left. That created some problems for me. Anyway, then we went back and forth. And the LA Times actually didn't want to change it because they knew that it was, they could see the numbers and they didn't want to change it. And we were going back and forth. And I started doing all these interviews. And in every interview, I had to start off by saying, yeah, we're not going to run out of water in a year, okay? We have groundwater, right? And so this is, the 1 year of water really referred to 1 year of water stored in our reservoirs, okay? But we have groundwater, and we have a lot of groundwater. The problem is that it's effectively unmanaged, and we're depleting it very, very rapidly. Okay, so I'll make that difference become more clear. But the things that I called for, so this is before the mandatory, so a lot of people in the press, which I love this, they're sort of connecting the op-ed to the response. So I was calling for mandatory rationing, and then the governor said, yeah, I think we should do mandatory rationing. And people are connecting that, and I think that's awesome. But I'm really concerned, the other two things that I called for was the emergency. We have this new groundwater legislation, which I'll describe a little bit later. We have it, but it's going to take years, decades to really implement. So effectively right now, because we don't have any water in our situation right now in California, is that there is no water in our mountains, right? There's no snow, like zero snow, okay? That, if we use a bank account analogy, the snow and the rainfall is like income, okay? It's like your job, that's how you get your money, right? The reservoirs are really like Folsom and Shasta. They're like a checking account. You just store a little bit of money there. They're really not meant to hold more than about really 3 years worth of water if you lose your job. You get about 3 years worth of water. So after three, we're in our fourth year job, there's very little water left in those reservoirs. And so that means, right, we go to the groundwater. Groundwater is like our big bank account. It's like our retirement account. It's like the strategic reserve, right? The big bank account that you only really want to touch in emergencies, right? And you certainly don't want to waste it all, burn through it all in just a few years. Okay? So it's a strategic reserve. It's like the big part of our storage. But in California, and I'll show you some of these images, we are actually burning through it pretty quickly. So we do have a management plan, but it is going to take a couple of decades for that to kick in. The long-term planning part really relates to global change. It relates to this mega drought stuff. When you think about the future, when you think about global change, the disappearance of the snowpack in the mountains, population growth, we don't know what's going to happen with agriculture. It's time to start planning, and again, I'll show you some pictures about sort of how the different regions of the world are changing. The water availability and water scarcity and water stress is changing in these different regions around the world. So when you look at this stuff, you realize, geez, we better start. If this is our water future, we have some big issues. We have some major things that we need to get working on. Maybe it's water rights, maybe it's water policy, maybe it's infrastructure. All those things could take decades. Water rights, water law, not my area of expertise, but I know enough about it to know that it's crazy, and most of it was written back when we were still, hunting for bears with muskets. So it doesn't really fit what we know today about how the earth works and how the water cycle works. The fourth one was public ownership, meaning us, meaning we have to take ownership of this problem here and really demand that our elected officials start paying more attention. Who saw Carly Fiorina, is it Fiorina or Fiorino, say the drought, this pissed me off, the drought is a man-made problem. Anyone see that? You did. Excellent. Okay, so that bugged me to no end. But we need to get educated on the problem. We need to talk to our, vote for, when we vote, use your vote, right? So vote for people who are interested in sustainability, right? Use your vote to show that you're concerned about what's happening with water. There's plenty of elected officials out there that actually care about it, and there's plenty that don't. So keep that in mind. Okay, so I want to talk about this satellite mission and some of the information that we get from it. The satellite mission is called GRACE, and we've been working with this mission since before it launched. It launched in 2002. Got a couple of human beings there for scale, so you can see that these things are not very big. And so GRACE stands for Gravity Recovery and Climate Experiment. It was launched in 2002. And it really functions like a scale in the sky. It is not taking pictures, right? It's not doing anything optical. What happens is these two satellites, they're up about 400 kilometers, and they're separated by about 200 kilometers. And as they orbit, they're in what we call a near polar orbit. So they're kind of doing this, and the Earth is spinning around like this. So they're able to cover the Earth just by going vertically, basically over the poles. So they follow each other around like this, like Tom and Jerry, like the old cartoons for the old people in the audience. And what happens is, why do I say it works like a scale in the sky? Because when the satellites pass over an area that has more mass on the ground, say because of snow in the Sierras, if there were any, right, then that area would be heavier, and it would exert a greater gravitational tug on the satellites. It pulls them literally down, not very much. A few millimeters, a few centimeters. But we're able to measure that displacement, the displacement between the two satellites and their vertical position. And likewise, when they pass over a place that's losing water, like the Central Valley in California because of groundwater depletion or because of a long drought, then that place has lost water weight. And so it exerts less of a gravitational tug on the satellites, and they drift up just a little bit higher in their orbit. Again, just like a few millimeters. But we can measure that. It's crazy, right? That we can measure the distance between the satellites and the vertical position with such accuracy, like thousandths of a millimeter. That by keeping track of the positions of the satellites are like the scale, and by keeping track of the sort of the position of the scale, just like if you step on a scale, right, and you crush it, you're pushing it down, right? A heavier person pushes it down more of a displacement. A lighter person doesn't push it down as much. There's less displacement. So that's what's happening with the satellites. They're getting pulled down when there's more mass on the ground. They float a little bit higher when there's less mass on the ground. And so by mapping out the position of the satellites, you're actually able to map out the regions of the world that are gaining or losing water mass every month. Okay, which is kind of cool. And The pictures really only come into focus, I would say it was launched in 2002, but to really understand what was going on, I think it took us till about 2009. Okay, and it doesn't, just some of the other numbers up here, it is not like super high resolution. It's not going to tell us anything about what's happening in Aldrich Park, but it will tell us what's happening over a region about the size of Southern California, right, or the Central Valley. So we're looking at tens to hundreds of thousands of square kilometers. So launched in 2002, and it could literally die at any moment. It's running out of battery power. And so we have its replacement lined up, and it's called the Grace Follow-On, which is very clever. And I only recently found out that the cool people call it faux. It's called faux. How's it going with faux? And so that's faux is going to launch in August of 2017, and it is on track. And it's on track for that launch, and parts of it are being built in JPL, parts of it are being built in Germany, will launch in the Ukraine. It's going to be just like the current mission. So it's not going to be new and improved in any way. And there are political reasons for that. It was pitched as what we call a climate continuation mission. Satellite, choosing new satellite missions is very competitive. They cost $1 billion. And why is my mission? Professor Matthew might want to study carbon dioxide. And you might want to have a satellite that tracks sea level rise. So it's a very competitive thing. And so we're able to get this approved by just saying, we're not doing anything new. We're just, the data that we're getting on the ice sheets melting, on the groundwater depletion that's happening around the world, it's so valuable that we need to just keep it going. And so NASA and basically the science community has agreed. So to kind of summarize and start to show you what some of the data look like, really what we're doing, by mapping out by keeping track of the position of the satellites, really what we're doing is technically we're mapping the gravity field. And we're looking at the changes in the gravity field, the changes in the gravitational tug on the satellites that are due to having more water over here and less water over there. So the reason that it works is because water is ridiculously heavy. And it is the heaviest thing that is moving around on the planet, right? People always ask about, well, how do you know that it's water that's affecting the gravity field? What about erosion? What about earthquakes? What about the wildebeest migration? And oil. What about oil? And all those things are important, but they're second order or third or fourth order compared to water. And we know it's heavy, right? You go to the grocery store, you carry a jug of water around. You go to the Trader Joe's, and if you're walking down there and you're coming back with 2 gallons of water, that's kind of a workout, at least for old dudes like me. Okay, so just a couple of other things then. What Grace is really telling us is the change, not the absolute amount. We have no way to really know the absolute amount of water. But what we're looking at is the delta, the change on a monthly basis. And it's all the water stored in a big river basin, say like the Sacramento River Basin. So all of the snow, the surface water, the soil moisture, the groundwater together. Okay? If we want to pull it apart and figure out how much is the groundwater, which is one of the things that we do, it takes other data sets. I'll explain that. And so this is what a time series might look like, a chart of the variations in the total water storage, how it goes up and down, wet season, dry season. This one starts in about 2005 and goes to about 2014. And so you see there's a wet season, dry season, but there's also kind of an alarming trend. This is the Colorado River Basin, right? This is the lifeblood of the West. And so, that is a river basin that's losing a lot of water, okay? And so you should be, I just told you in advance, you should be alarmed by about 75% of the slides that I show you, right? Just for a frame of reference. Okay, we also, so we look at charts, we look at animations. Here's one that is looking at California, and the reds are drier than normal, and the blues are wetter than normal, and we're kind of cycling through. We're going through the last drought of 2006 through 2010, and then we're going to get a little bit wetter in 2011, and then we're going to slide into the current drought here. And so it's just be getting wetter. So if you watch that as much as I do, eventually cry yourself to sleep. So now we're looking at, so now I want to talk about what we see from satellites about the drought. And this is a time series, a chart of the ups and downs of water storage, total water storage, in the Sacramento and the San Joaquin River basins, which are outlined in red. Okay, so this is basically how all of the water is changing, how it's going up and down. And so you can see, there's a lot of information here, but especially as you get towards the last three, so it starts in 2002, and this endpoint is roughly November of 2014. So, in fact, we don't have any new data, so this is the complete data set that we have right now. And November is always the low point in terms of water in California, so this is sort of like where the drought has bottomed out at this, I reserve, let me retract that comment. Anyway, we're at a pretty low point at this point in November of 2014. And so what you see is going back to 2011, right, you see this pretty big drop. And when you look at the numbers, we see that California, or the Sacramento and San Joaquin River basins, which is really where all the water is, have lost, choose your units, 15 cubic kilometers, that's 12 million acre feet, or 8 trillion gallons of water per year, going back to 2011. That is more water than all 39 million Californians use for domestic and municipal supply. So it is, this is a technical term, it is a shitload of water. So, the other things to notice about this is that, so this point here is our wet season, right? These peaks are our wet seasons, right? If this works. That doesn't work. Okay, so that peak, the last peak all the way over on the right, that's our wet season. That's the wet season. That's the winter of 2014. And you see it doesn't even rise to the level of the previous dry season. Maybe it's sort of higher than one of the dry seasons. So our wet seasons are not even rising to the level of the dry season. And if we plot the new, when we get the new data, that peak will be sort of over here, just like near the corner of the plot. So it'll be even lower. Okay, so we're losing all this water. About 2/3 of it is from groundwater depletion. Here's what some of the graphics look like. We can map it out. These are sort of our version of the drought maps, not too different than what we saw in the animation. The other thing, I want to point out about this history here that goes back to 2002 is that we see a few different timescales of the drought. And so there's the current drought, but arguably we could say that it started in 2006. Or really we could say in the whole time period that we've been watching with this satellite, California's been losing water. Okay? And so that's sort of the realization that I have come to, is that we are in the long term, it's probably true for the Colorado River Basin too. In the long term, California's been losing water for a long time. And the reason is that the snow and the rain sort of come and go each year. They're the renewable part, right? And some years we have more, and some years we have less. Like this year we have none. It comes and goes every year. But the groundwater, as I will show you, just as this, it's been in a steady decline. Okay? And so when you add the two together, this is what you get. So the ups and downs are sort of modulated by the snow. Do we have a good rainy season? Do we not? And a lot of the trend is coming from the groundwater depletion. So we're losing water in California. Just a couple of research slides. One of the things that we've been able to do, it's very difficult to say when a drought. Should I just ramble on? I mean, do you want me to stop it, or just go, just ramble? All right. I'll only ramble until I get to the last slide, and then I won't ramble anymore. So it's very difficult to say in hydrology, when does a drought begin? When does it end? And the reason is, our data are all over the place. They're stored in different places. It's not really clear what we should be looking at. Is it a drought if we're just talking about groundwater depletion? A lot of it's human management, right? So what's happening with the reservoirs? Is there a lot of water? Is there a little water? And so we've been able to get past a little bit with these GRACE data. So that chart on the top That's our time series of the changes in the total water storage in the Sacramento and the San Joaquin River basins, right? So the one we just looked at. And the middle one is like the average of the upper one. And a way to think of it, I like to think of it as like if you started monitoring your weight for the first time, and you're doing it every month. And so, okay, not for the first time, you started 12 years ago, and you've been plotting your weight, right? And so what actually happened is up at the top. That's your chart of your weight losses and your weight gains. And so you start to understand, oh, what's the normal, what's the average range? That's the middle. How much do I gain on average? I gain 5 pounds in the winter, or lose 5 pounds in the summer. And so that's the middle part, right? And so when you have a really big year, like, I don't know, a huge Christmas or something, and, lean times over here on the right, you can start to understand, okay, how much, in terms of water, how much wetter is it than the normal wet conditions? The normal wet conditions are in the middle, the peak's in the middle. And so you can compare the top to, 2000, whatever that is, 2005, 2006, right? And you can also see how much drier it is than normal dry conditions. We should expect dry conditions, but we also need to understand what are the deviations from the dry conditions. Just like, was it really, was it an incredible summer and I exercised so much I lost 30 pounds between whatever June and August. Okay, and so that's what we've shown here. We were able to, is shown in red. We're looking at how much drier than normal dry conditions we are. Okay? And so what that means is that we're able to identify when a deficit or a drought period, right? When do we dip below normal dry conditions? And so you can kind of see it here. Here's when a deficit or a drought actually begins, right? Here's where it ends. And we can actually put numbers on how big it is. How big is that deficit? How much water will it take to get back to normal conditions for that time of the year, right? Last year, that number was 11 trillion gallons, okay? So that last year is right at this time. And the reason that the deficit is the biggest in March is because that's when we'd have all the snow. That's when we have the maximum storage, okay? And so last year, that deficit was 11 trillion gallons, which, you heard me use that term before. So it's a lot of water. You can see that the size of the deficit is increasing pretty steadily. And so just, again, we don't have our data for right up to March, but if you just extend that line to right now, to March 2015, then the deficit would be about 12 trillion gallons of water. So that tells us something. Not only is it a staggering number, but it's a target. It says that's how much water, more water, we'd have to get in storage. Not rain, but how much water in storage, meaning in our snowpack, right? Replenishing groundwater, replenishing our reservoir. We need 12 trillion gallons this year. So if we could magically come up with it, steal it from, I don't know, Oregon or something, that's that's how much we'd have to steal. All right, groundwater. And so I mentioned that we will be relying more and more heavily on groundwater this year. In a normal year, so this just defines what groundwater is. So surface water is the water on the surface, in the rivers, the lakes, the reservoirs. Groundwater is the water that's stored in our aquifers underground, okay? In soils, in rock units, which are called aquifers. To get it, we have to pump it out, right? We drill wells and pump it out. In a normal year in California, our state average water supply is about 2/3 from surface water, from the snow and the rain, and is stored in the reservoirs, and 1/3 groundwater in a normal year. Right now, we're about 75% groundwater and 25% surface water, and because the reservoirs are progressive, they're not being refilled, and so the reservoirs will, as the reservoirs empty out, we will be using a larger and larger fraction of groundwater statewide, 80%, 85%, we'll probably get up to about 90%. Okay? But groundwater is not unlimited. Right? It took the water that lies beneath the Central Valley most of it was infiltrated and filled those aquifers about 20,000 years ago. Okay, so it's not going to be replenished anytime soon. All right, so how do we get at it with GRACE? I said before, GRACE really sees all of the water together, all of the snow and the surface water and the soil moisture and the groundwater together, right? And so that's what that equation on the top is saying. The change in storage that GRACE is showing us is really the sum of the change in the soil moisture and the snow and the surface water and the groundwater. And so if we want to solve for just a simple algebraic equation, we want to solve for what the groundwater storage change is. If you rearrange the equation, right, the first term, delta S total, we get from GRACE, and we just have to subtract the other stuff. It's well, it's not simple, but simple mathematically, but not simple logistically, not simple in practice. We just have to get other data for the change in the snow and the change in the soil moisture and the change in the surface. And that's sort of what I tried to show here. If we were to just estimate what's happening with the blue stuff, we have to subtract off, right, the other stuff. Another way to think of it is, if you go back to the weight analogy, and you have a chart of how much weight you've gained or lost every month, but if you want to know how much weight you've gained or lost just in one part of your body, your head, right, then you have to have data on all, and I don't know how you would get it, but you have to have data, right, on all the other parts of your body too, and then you subtract it. And so that's what we do. And we get the data from different sources, and it depends on where we are. If we're in the United States, we have pretty good data on surface water storage, reservoir storage, snow. Nobody really measures the soil moisture, so we have to use computer models. But if you are trying to look at the Middle East, right, or India, or China, these are all places where we've done studies, you really have no hope of getting that data, okay? And so we rely more on, if we're lucky, if there's other satellite measurements, we rely often on computer models to estimate what those other components are. Now, okay, more about groundwater. If you didn't know, it's really most of our water. It is 96% of the unfrozen fresh water. We're all very focused on the surface water because we can see it, right? And it just makes sense that we can see it, it's readily accessible, and it captures all of our attention, but the bulk of the water is underground. It is the major source of water, really for about a third of the population. It supplies almost half of the water for irrigation globally. In the United States, over half of the drinking water, and about 60% of the water used for irrigation. So, it's just a critical reserve. It's a critical component of the water supply that it's not quite like Rodney. Well, it sort of is like Rodney Dangerfield. Again, another another reference that your parents would understand. But it doesn't get, which his line was, I don't get no respect. And that's what the case for Drought. Like I mentioned, it's a strategic reserve in times of drought. And in many places around the world, the withdrawals are unmonitored, unmanaged. It's certainly true in California. It's true right now. But we only got this legislation passed in September. And especially if you go to the developing world, it's sort of a free-for-all, and it's absolutely crazy. So I've sort of written extensively on this topic, both globally and in California and in the western U.S. So the Central Valley, the part that's shown in blue, right? Turns out, I didn't know this when I moved to California, and I actually had to start driving through the valley to really start to appreciate what was going on there. Who has not been? Who's been to the Central Valley? Okay, you people need to, the rest of you people, need to get in a car and go up, get on the 5, go up and over the grapevine and go down into the valley. It is a vast expanse of agriculture. At one time it would have said agricultural splendor. But what always stuck out to me was the fact there's not a river, a reservoir, there is nothing in sight. And so, as a hydrologist, from the first time I drove into the valley, which was probably about 2005 or so, I wondered, where's all the water coming from? And as you drive around, you also see the signs, the billboards. Does anyone know the billboards that I'm talking about? Dust Bowl. Congress created Dust Bowl. Badass Congress created Dust Bowl. And food grows where water flows, and like water equals jobs. And so, I started wondering about what was going on, and that's really what motivated me to get into it. But the Central Valley, turns out, is hugely productive agriculturally, and a lot of it's fueled by groundwater. And who knows what the biggest products are right now? Some of the biggest crops that are grown. It doesn't have to be the biggest crop. Yeah, nuts, right? So they're the big thing right now because they're high value crops. But the problem with walnuts, almonds, nut trees, and even vineyards, they are perennial. They're year round. And so once they go in the ground, if you're planting an annual crop, like, I don't know, tomatoes or something, I'm not a farmer, I have to really think of an annual crop, tomatoes. If it's a dry year, you don't have to plant it. Right? But once you make the investment into trees or grapes, you have to water year round. And wet year, dry year, you have to do it. Right now, if you drive in the valley, there is a rush. It's an almond boom. There's a rush. A lot of it's because, actually, it's sort of a perverse side of the drought. There's a rush to get the trees planted because the groundwater, if you own the land, you can pump the groundwater. You have the right to the water. And so there's a rush to get the plants to get the trees in the ground before this legislation kicks in, before the government says no more almond trees. And so there's a rush to, and there's a whole sort of investment thing that's built up around. Anyway, hugely productive, tons of citrus, mostly, fruit and produce, huge dairy, by the way. And when we have animal agriculture, we have to feed the animals, and that means we need to grow the feed. And the big thing that cows like is alfalfa, and alfalfa is exceptionally water intensive. Well, I think even more than the nuts, but I'm not really sure. So anyway, it's such a big region. It sucks up literally a fifth of all the groundwater demand in the United States comes from the Central Valley. It's the second most pumped aquifer in the U.S. Does anyone know where the other big aquifer / food producing region is in the U.S.? Around the Salton Sea, actually, it's not the biggest, but it's big, right? Coachella Valley. It's before there was the concerts, there was agriculture. The Ogallala, or the High Plains Aquifer, it goes right up the middle part of the country, and that's mostly grains. And here in California, it's mostly produce, fruits, vegetables, all the olives, all of the almonds. Since the day we started agriculture in the Central Valley, we have been depleting that aquifer. We've been pulling it out faster than the water is being replenished. That's mining. We've been mining groundwater since 1920s, 1930s. And one of the things that happens is that the ground subsides, the ground sinks. It's like letting air out of a bicycle tire, right? The tire flattens. You pull the water out, pull that fluid out, and the ground actually compresses. Not everywhere, but in big parts of especially in the San Joaquin, the southern half of the valley. Okay, and so this is a famous photograph of a USGS scientist named Joe Poland standing next to a telephone pole, and marking where the ground surface was in 1925 compared to 1977. That's a foot per year of subsidence, and that's still happening today. There's some places that the ground is sinking at 1 foot per year. Of course, if your house is on that, right, or if there's a bridge on that, or if there's a road on that, right, or buildings on that, that's not good. Okay, so just a couple of pictures that show how we get at estimating the groundwater, and then what the long-term groundwater picture is. Then I'll talk about sort of bigger picture, global groundwater, and then we'll be done. So this just shows that the algebra of starting with the total water storage for the Sacramento and San Joaquin River basins from Grays, and subtract to get to the groundwater. We have to remove the soil, the weight of the water above the groundwater, so the soil moisture, which is just the water in the soils, and the water in the rivers and the reservoirs, and the snow. And so that's the snow in the upper right. These are reservoirs and rivers on the left, and this is the soil moisture. So you just take that one, subtract 1, 2, 3, and you're left with a groundwater chart that looks like this. And so this shows very clearly what's happening with groundwater depletion in the last drought, the 2006 to 2010. Then we get a little bit of recovery. Here we are now. When we update this, we'll probably be sort of right down here in the lower, right, so again, these last 3 years, we've been losing about almost a little bit over 5 trillion gallons of groundwater per year for the last, going back to 2011. And so, it's about enough. Let me see how much we're at 10. It's about a Lake Mead worth of groundwater. It's about how much we've lost in the last 3 years. So I want to show you a couple of other charts that kind of put it in perspective what's happening here. Same groundwater time series, right? This is our estimate of the groundwater. We've isolated it from the gray signal. What are all these colors in the background? They are showing us, we're looking at surface water availability versus groundwater availability. Groundwater is the black line. We just estimated it by the methods that I showed you. And these blue and red lines are these allocations of water from the north to the south, through the canals, through the 2 big canals. The orange one is the State Water Project, and the purplish one is the Central Valley Project. So that's how we move water from the north to the south. And the amount of water that we move every year is allocated by either the federal government or the State Water Resources Control Board as a percent. Remember at the beginning of the class, I was saying 0%, whatever, right? So good allocation is 100% of whatever the number is, whatever that total amount is. So 100 is awesome, and 90 is not bad, and 0 sucks, right? So what we see very clearly then is that when surface water availability increases, right, from the first 3 years, right, we're going from 70%, 80%, 90%, 100%. Hey, the groundwater recovers. This is not rocket science, but to put it in a chart like this is really an eye-opener for our water managers and for our elected officials, okay? Well then, no surprise, last drought, 2006 to 2010, the allocations were cut way back, got down to whatever, 20-ish%, 30%, and so the groundwater, right, took a big hit. And so it's like 1-to-1, right? So surface water is available, a little bit of a wet year in 2011, and the groundwater recovers, and then bang, here we are in the current, right? In the current drought. And our allocations now are like 0 and 10, 0 and 20. So when we update this, right, we'll see that that line sort of extends again right down to the corner. Right? So this is, we have to be thinking, when we talk about sustainability, of managing our surface water and groundwater together. Right now, we just think about managing the surface water, and we're literally just saying, yeah, whatever, about the groundwater. All right, long term. Now we're combining, we're going back to 1962. We're looking at the groundwater levels in the Central Valley. Okay? And so you can see they've been in steady decline since 1962. We're combining with USGS data shown in red and our GRACE data shown in green. And the colors in the background represent a wet period versus a dry period. So it's still getting at this sort of surface water, right? When it's wet, groundwater recovers. And when it's dry, like in the tan, those are droughts, we use a lot of groundwater. Right? And the intermediate colors are sort of moderately wet, moderately dry. So there's a very clear pattern that we've been doing for decades, which is a little bit of recovery in a wet period and a big decline in a drought, and a little recovery and a big decline. It's like a tennis ball, right, bouncing down the stairs. It goes up a little bit, but basically, it ends up at the bottom. So the question we have to ask is, so this is sort of the definition of unsustainable. And one of the things that we know, or there's several things that are happening as we get deeper and deeper into the aquifer. The ground is subsiding, the quality of the water is degrading, streams are being depleted, it's getting more and more expensive to dig wells. Some of these wells cost $100,000, $200,000. So there's inequities that are arising. Only the bigger farms and the wealthier farmers and wealthier individuals can afford to dig the deeper wells and pay the greater pumping cost because you have to more electricity to pump the water over a greater depth. Right? And so, what we're seeing is that the workers who work and live near the farms actually don't have access to water and can't afford to dig deeper wells because of the farm that they are actually working. Just some slides to show. We're moving towards doing all this with remote sensing. This is kind of a NASA. Put my NASA hat on. Just got a bunch of other cool missions coming down the pipe. This is the one that shows some of the work of one of my colleagues that uses radar to track the subsidence, the sinking of the ground. And this was sort of pre-drought, so we're up around the areas called El Nido, and so he sort of discovered that this was happening. We didn't really know. Like we knew, in some places where it was happening, but he used some radar data. His name is Tom Farr. He used some radar data to show that during the drought, the subsidence rate from the current drought, shown here, the colors are here, and so that's sort of a big subsidence bowl, right? So it's actually making a big sort of depression in the ground. And some of those rates, those are inches. So the reds and the purples and even white there in the center, that's a foot per year or greater. Ironically, a lot of the infrastructure that's being destroyed is the water delivery infrastructure. So the canals that go right over that. Okay, I wanted to now zoom out to Colorado River Basin, United States, and then we can all cry together about the global situation. The surface water groundwater thing, it's not just in California, right? So we did a study, came out last summer, that looked at the Colorado River Basin, the lifeblood of the American West. There's the 7 basin states, there's Mexico. I don't even remember how much water we get from the Colorado River Basin, but we use it here in Southern California. Most of that Colorado River Basin water gets used in Southern California. We drink it. And what we see is, I pointed this out before, this decline in water availability, right? The total amount of water shown on the top. But when we split it up into how much of the water is surface water in the big, huge reservoirs like Lake Powell and Lake Mead, that's what's shown in red. Okay? They're relatively flat compared to the groundwater. Okay? So it's another case, is very much like what's happening in California. We're super focused on the surface water, and the groundwater is unmanaged. And in the case of the Colorado River Basin, right, it is the reason why we see this decline in water storage. Groundwater, people are so focused on the surface water, and while everyone's focused on the reservoirs, groundwater is quietly disappearing at a rate of about 6 or 7 to 1. Okay? And so we have some structural problems, policy problems, because Colorado River Basin is, it's an interstate basin, but groundwater is managed at the state level. So you can't even get the basin managers to talk about groundwater and what's happening with groundwater. So it's really frustrating for someone like me to see that and write papers about that, but not much is being done. Okay, United States. This is a map of the trends in water availability and freshwater storage in the United States for basically the whole gray spectrum. The blue is gaining, the red is losing. Okay? And so you see a couple of things, that the northern half of the country is wetter, and the southern half of the country is drier. And you see that our big food producing regions pop right out as being places of tremendous water loss. And a lot of that, from our other studies, we know it's from groundwater depletion. So the Central Valley, and then the southern part, so over this Texas Panhandle, that is the southern part of the Ogallala or the High Plains Aquifer, the other big food-producing region in the United States. So this is not good, right? If we're having groundwater depletion happening in the places where we use it to grow food, the future does not look particularly bright. Okay, this is where we start to bust out the violins and start to cry. We're going to start to do the global tour. These are studies that we've done around the world. So now we're doing the global tour. We've left, United States, California is on the top. These are other very similar groundwater studies, and these are our groundwater plots. These are rates of depletion. Okay? All you really need to know is that India is the worst, and the Middle East is right up there. And actually, California right now sort of ranks about third. Okay? And those are those sort of like before and after pictures, like the green at the beginning and the red at the end, like I showed you right at the beginning. I'll show you this one. I thought there were some animations, but I'll skip them if they are there. This is the global map. This is where you should really start to get concerned. Okay. Again, red is losing water, blue is gaining water. Okay. The biggest losers are the ice sheets, right? The top Greenland and Antarctica, and after that, alpine mountain glaciers like Alaska and Patagonia. But just about all those other red spots are the world's major aquifers / food producing regions, right? All over the world. Okay? And they're concentrated in the arid and the semi-arid parts of the world because that's where we rely heavily on groundwater. And so, you've heard of some of these, the Central Valley, and I mentioned the Ogallala, and here's the Middle East, and the North China Plain, huge, right? Just Beijing, growing tons of food there. Actually, this is northwestern Australia. This is actually water used for mineral mining and now fracking. It's not an ag region. No one lives out there. Mining uses tons of water. This was India. India is the #1 greatest rate of groundwater depletion in the world. Middle East is probably #2. Down here, South America, water in the aquifer, losing water like you read about. Don't know why that's there. Don't know why that's there. Sloppy work. We're going to skip the animations. And I want to throw in a little bit of climate change. One of the things that the IPCC models suggest is that the wet areas of the world are getting wetter, and the dry, meaning the high latitudes and the low latitudes, and the dry areas of the world in between the mid latitudes are getting drier. And we've been looking at these data for a long time, and I think that we're that's actually what we're seeing. We're seeing the wet areas getting wetter. That's the blue. The dry areas getting drier, and so I always ask the question: are we seeing what these models are predicting? And then embedded in the dry parts getting drier are the hot spots for groundwater depletion. Whoa, it's a crisis. Pam, way over time, right? So we can skip over the international call to action, and let's just get back to California. So it's a global crisis, okay? Another conversation for another day. I've gone pretty long. But I just want to, we can all go to our sort of Q&A now and get some interaction from you guys. So mandatory rationing, right? I do like a bazillion interviews now, and the #1 question that's now coming up is, what about agriculture, right? Do you folks know how much water, did I say it already? How much water is used for agriculture? It's like 80%, okay? So, but yet the rationing only deals with the 20%, which is the domestic and municipal. What do you think about that? We can talk now, right? We're
Absolutely.
we're basically done. I've got a couple of other goodbye slides, but I think this is the important part. Yes, you have a question?
Yeah, I have a question based on agriculture. So I'm not well versed in this, but what kind of irrigation is it used?
Yeah, we use a variety of irrigation, from the ridiculous, the spray irrigation, to drip irrigation, to flood irrigation for rice, which is absolutely, I was going to say absolutely nuts, but that agriculture fine. But yeah, we use all kinds, and we really need to be working on it. I mean, that is the way to say, we have to decide how much of our economy do we want to be an agricultural economy. How much water do we want to devote to it? How much does it actually need? How much could we cut back? We could probably cut back without even really trying about 20%. Yeah, up in the back.
What are your opinions on dry competition?
Well, I think it's great if it rains, right? And if it doesn't rain, it's not going to work. And so it's the groundwater that's really fueled agriculture here in California. So, we have the mandatory rationing. Personally, I think it's a good thing. The other thing that's popping up is, I don't know if you've seen these stories, but now, like LA Times, there's great inequities. Basically, wealth and wasting water are highly correlated. And so, like, the biggest water users happens to be Newport Beach. So there was just an article in the paper today about the mandatory restrictions. And so on a per capita basis, I think people in Newport Beach use 200 gallons per day. And so they're being asked to cut back 35%. So that still means they're using 120 gallons a day, right? But then there are other towns that are much poorer and are already only using 55 gallons a day. And they're actually being asked to cut back to by 10%. So cut back to 50 gallons a day. So that's crazy, right? So mandatory rationing, I think the handwriting is on the wall for agriculture. The governor has already asked for detailed reporting from ag on water use. He was on This Week with George Stephanopoulos on Sunday, and he basically said, yeah, we're not going to touch agriculture right now, and it's really important, and there's lots of jobs and lots of food. But, if the drought continues, we may have to. I think he's basically putting them on notice. The emergency groundwater plan, to me, this is critical. I think we are going to get screwed this year. It's another technical scientific term. And the reason is because there are no restrictions on agriculture and they have no surface water. So just like I showed in those charts, right, the surface water availability is there. So they are going to go deep, literally, on the groundwater. And there is a rush. If you go take a drive, field trip. You'll see. There's all these baby almond trees that are going in the ground, and I think the vineyards. And investors call me out and say, like, what do you think? Can I make a lot of money? And I don't know, it's a conflict. The answer is yes, you can make a lot of money. But do you really want to? So the lack of oversight of the groundwater right now is, when we look statewide, is the biggest issue that we face, and no one is paying attention to it. The long-term plan, when I think about this mega drought stuff, when I think about, I showed that picture of the wet areas getting wetter and the dry areas getting drier. Even in California, we have a wetter southern half and we have a wetter northern half and a drier southern half, right? We're already fighting about, farmers versus cities. We have to start planning now so that we can decide as a state, how much do we really want to allocate to agriculture. People think leaving water behind. Some politicians and even some water managers think that it's crazy to leave water behind for the environment. We call it environmental flow. Actually, like leaving water in a river, some people think is a waste. Anyway, we have to make informed decisions about how to allocate water amongst the many competing uses. Agriculture, economic growth, industry, energy production, human use, environmental flows. These are all things that are super, super important. But the direction, the direction that climate is headed and population growth is headed means we will see, right, with the wetter northern half and the drier southern half, the haves and the have-nots. We've got the deeper water table, so only the rich people can dig the deeper well. And again, now you're talking $200,000 to $300,000 for a well. And so, there's these haves and have-nots that we need to start working on, minimizing that from now. So whether we're talking about desal or, whatever, more sewage recycling, better water pricing. Do you have a question?
Yeah, I actually had a question about the desalination.
Yeah.
Do you know the prospects of them and the pros and cons?
Yeah, so the pros are it's, turning wine into water or whatever. Anyway, bad religious joke. But it was Easter, so I'm not a comedian. So yeah, it's great, right? If we could, if it were economically viable, which it's not right now, So the pros are, yes, you can get water from seawater, right? But the cons are outweighing the pros right now. And it's very expensive, energy intensive, and so those two kind of go hand in hand. And then, what happens is the way desal works is it's called reverse osmosis, but the water gets pushed through a filter, right? And so the filter, it's like a membrane, so that's what filters out the salt. And so you're left with this like nasty, right, salty brine on this side, and the clean water on this side. And the brine is toxic. And we don't have a solution for what to do with the brine besides throwing it back in the ocean, which is not cool. You're like if you're a fish near the outflow. But I think that those are solvable problems. I do. I think if we treat the brine like a commodity, a lot of work needs to be done, but I think the long-term prospects are pretty decent. Yeah. Well, a lot of it is the energy cost, right? And so then there's also the greenhouse gases associated with energy. So if you could use renewables, right, then it could be better. This is the ownership problem. This is sort of us, right? So again, I just want to emphasize, I think that as you guys as young voters, use your vote to vote for sustainability, to let your elected officials know that water is really important to you. I mean, that's basically all we have, right? But there are a lot of... The nice thing about water is for the most part, it's bipartisan, right? And so it doesn't really have to be politicized. People try to, as I mentioned, a little bit, but for the most part, politicians are engaged, especially, you have to be kind of not the brightest politician, right, in California, and try to ignore water stuff. I think that's probably a death knell. So I'm done. Should we do more questions, or? Yeah, I've got, obviously I can, yeah.
So about public ownership,
Yeah.
I was just wondering your opinions as a UCI student, what could we do to, I guess, increase water consciousness on campus? And more so than just talking about the drought, but also showing how there's a water footprint in so many things, like the clothes that we're wearing or even the lights that are generated.
No, I feel bad. You should turn out the lights. No, I mean, those are great ideas. And so, talk to your professors about doing class projects, get involved in the clubs. I used to hang with who's in the Green Initiative. I used to hang with those guys a little bit. Who knows? You have the cool T-shirts? Anybody? No? TGIF? Sustainability clubs, right? Just get involved, take the classes. There's a lot that you can do. Also, our facilities people are super engaged. So our vice chancellor for, I guess it's facilities, Wendell Brazet, he's amazing. I mean, he's really into it. And so I think he's more than willing to engage with student groups. Although the guys who took my class, remember, we talked to them a little bit in class. We tried to get the deans to turn off the fountains. They wouldn't do it. Then I went to JPL. They turned off the fountains the day I arrived. Like, Jay's here, fountains off. Yeah, Vice Chancellor Brazet, he's a good one to talk to and see. And also there's Abby and there's a sustainability initiative on campus, right? Professor Math, he can hook you up. Okay. Yeah.
What are some of the easier ways that we can regulate agriculture to help save water?
That's tough, right? It's kind of like, they're not quite like the oil companies, but some of the big ones, I guess, probably are like the oil companies. So it's hard. Now, water is getting super expensive, and so they are beginning to, there's been kind of a changeover, I'd say, in the last 5 years, from having no interest in water scarcity and sort of being in denial about it, to realizing okay, yeah, water table's dry. Oh, they look up at the mountains, I don't see any snow, right? And they look at their wells, and the wells don't reach the water table anymore. But I don't know how you really impact them. And like right now, the governor, right, has left them, they're basically untouched. They're basically being forced to use the groundwater, you know, implicitly being told to use the groundwater. So I don't know. I wish the groundwater legislation kicked in faster. I don't have a good answer for that one. They're tough. Yeah.
I have kind of a two-part question.
Yes.
First of all,
You better give it to me one at a time. I'm not going to remember both.
okay, so, do you think it's better for legislation to focus more on us as civilians or on corporations? And if they focus on corporations, what do you think is the best way to curb them so that they can actually get to where they
Yeah.
want?
Well, so we actually have to do both, right? And although, you know, I mentioned that agriculture is really not touched by these restrictions, right now, because of the drought situation, we're actually disconnected from, we too are disconnected from those aqueducts. And so that means that the water supply that we have is local, right? And so it would be easy for us to say, oh, well, why should we do anything? Agriculture is not doing anything. But we have to conserve and preserve our own local water supply. So it's important to deal with people. Dealing with people is always good. But most of the water use, so now if we're going to look at statewide numbers, then you are talking about business, right? And we're talking about agriculture. But beyond agriculture, if you could, you know, a couple of people from Pepsi just came to visit me, and it was kind of creepy. But the reason for talking to them, or to Walmart, or to any big corporation is, you know, they control a lot of resources, and if you can get them to do things, you can really affect, maybe I'm naive, but I think you can really affect sustainability by working with this. This is sort of the frontier, I think, is looking at the big companies. Now, whether you have to force them to do it with legislation, or whether, you know, you can convince them somehow. You know, that's where I think our voting and, you know, our feedback becomes very important. If we say, you know, we want to know the, like, you know, someone over here was saying, we want to know the water footprint of those T-shirts that you sell. And we're not going to buy it, right, if it uses too much water. That's the kind of thing we could push for, right? Water footprint legislation or something. Okay, part two.
Oh, that was, I kind of combined it.
Oh, you did, all right. Excellent. Excellent. I think that could be done.
Got one.
Oh, yeah.
You had, you were God, could you explain?
I am. Yeah, I think you did.
What do you think is a possible groundwater plan?
Well, a lot of it, you know, there's that old saying in management, right? You can't manage what you don't measure. And so monitoring at the individual well level and reporting of water use, water withdrawal, water quality, right? That's number one. Another sort of basic, you know, I think makes a lot of sense. If somebody withdraws water and then returns it, right, to the environment, so you're using it for agriculture, you're using it for whatever, your mining company, right? When you return it, it should be returned at the same or better quality than when you withdrew it. So those are sort of fundamental. So of course limits, right, on the pumping. That's what I would do. I do think I'm God.
Two more questions.
Jay, I want to give you a takeaway.
Yes, thank you.
Opportunity is to find out how many voted last time and how many are going to be sure to vote the next times
Here, in this class,
in this class.
how many people voted in the last election?
2014.
2014 election. We're talking about presidential election?
The last election.
The last
2014.
election.
Right.
How many voted? I voted. Okay,
So
next
that's-
election.
And so then, how many are planning on voting the next election?
You heard her. How many players voted the next election? Everybody should be raising their hand. You have to vote. When I was your age, I admit, I was not interested in voting because I thought I wasn't going to make a difference. And that is just, turns out to not be true. Okay? So you can make a difference. Get out there and vote.
One last question.
Since you had said there was a really high probability of a mega drought actually occurring, in terms of long-term planning, do you think the simulation or study that UC Davis did as far as campus economy and water supplies, how applicable do you think that is to our current situation?
You mean which, I got confused.
The one where they simulated, I think it was like a 70-year drought or something
Oh, yeah,
like that.
yeah.
How applicable do you think that is to our current situation?
I don't think it is I think that really relies on the combination of increasing temperature and changing atmospheric pattern. And this dry area is getting drier and stuff, so that would be the southwest. So if you're asking, I think that we could experience something like that right now. I don't know, but I don't think it's very likely. But I do think, the future is very, very difficult to look at your crystal ball and think about what life is going to be like. But I think that the climate is going to be much, much different, and in ways that is difficult for us to understand. More variable, more flooding, more drought, and spatially distinct the haves and the have-nots, and we're in the have-not zone. So that's where we're headed. It's up to you.
This last question.
Yeah.
The very last question.
This is the last question.
This is really the last question.
As opposed to not really the last question.
I was just wondering, do you think that getting people to eat less meat would make a big impact?
Yeah, huge. Yeah, cows are a lot of water goes into feeding the cows. Yeah. And then the processing and the packaging, the water footprint of the cow. And I'm sorry, because I really do like hamburgers. And all kinds of meat. But I actually don't need to eat that much. And so this is a problem also in the developing world, right? And so, look at China, right? Their quality of life is increasing, and they're going to be more meat, and they don't have the water. So I don't know if you know this, but they're like buying up the water rights in Africa.
So
Let's be.
take a 15-minute break. I want graduate students to come down here quickly, but before anybody does anything, join me in thanking Dr. Famiglietti for coming.